right. Sketch the resonance structures for the nitrate ion, NO3 minus. So just as a first guess, I usually just pop in the atoms around the central with their typical valencies. I shouldn't have done it that way. And remember, a Lewis structure is just representing each of the electrons as dots. And okay, so then if we just join up the bonds like this, it looks funny, but in the end, what we're going to have now, first of all, we need another electron popped in there because we've got a minus charge, right? So this is all neutral, so we need to pop in an extra electron. We can make sure that we didn't mess anything up by counting. So we've got 5 valence here. Each oxygen has 6, so there's 6 times 3. And then this is an extra 1 electron. So 6 times 3 is 18, plus 5 is 23, plus 1 is 24. So there should be 24 electrons. So here we've got 7 around nitrogen, oxygen, 5 around nitrogen, 6 around oxygen, and 6 here. 7 and 5 are 12, and 12 is 24. So we've got the right number of electrons. If we look at this structure now, so these are both 6, so they're neutral. This guy has a -1 charge. So the whole thing has a -1 charge, so that's good. But these oxygens don't have full octet, so they're not very happy. We can give them a full octet by taking away one of these electrons on nitrogen and say popping it over here, and then taking this electron and this one and forming another bond. And so then we would be able to complete all of our octets. So drawing this now in less of a hand-waving way. We'd have nitrogen, oxygen, oxygen, double bond, oxygen, and drawing dots for each of the electrons. Now summing everything up, so we've got 7 electrons here, 7 electrons here, 4 electrons here, and 6 here. So 7 and 7 is 14, and 10 is 24. So that's all of our valence electrons, so we're good. This guy has 7 around it, and it normally wants 6, so it's a -1 charge. This guy wants 7 around it, normally wants 6, so it's a -1 charge. Nitrogen has 4, it normally wants 5, so it's a +1 charge. So we've got a bit of charge separation, but that's okay because we've got full octets. And the total charge will be -1 because -1 + 1 - 1 is -1. And so this looks like our structure. Okay, so now we're going to sketch the resonance structures. So we've got our oxygen, nitrogen, oxygen, oxygen. Okay, so our resonance structures just come from the fact that we can move this double bond up and then form another double bond and have the exact same, have the structure still be viable. So this is another viable structure. The only difference now is that the charges have moved. So now these ones are negative charged, whereas here these ones were. And then we can do this game again. So we can move this up and move this down and get another resonance structure. And again, the charges have now moved. But this is still viable. Now, resonance structures are not real. They're not actually happening. But what they do represent is that the molecule would exist in an in-between state of all three, meaning rather than two of these oxygens holding a -1 charge, each oxygen likely has roughly -2/3 of a charge, and the nitrogen almost certainly has a +1 charge, as it has a +1 in all three resonance structures. And so the electron density will actually be delocalized through the entire structure, which is what this represents. So it's still a handy tool for describing the molecular structure. So the hybridization of the nitrogen atom is sp2 in all cases, which means, so the reason why it's called sp2 is because it can form 3 sigma bonds. So the number of sigma bonds is just, I believe it's actually represented like that, sp2. So the number of sigma bonds it can form is just 2 plus 1 for the s, and then it forms 1 pi bond. Although in reality, we have something more akin to a third of a pi bond in each case. But so these are the sigma bonds, and which of the 2 lines I call sigma and which I call the pi is meaningless. I'm just pointing out, I'm just identifying what I am calling the 3 sigma bonds and the single pi. But you could call either of these 2 the pi, it really doesn't matter. Describe the orbitals involved in bond formation. So the sigma bonds will be more central to the vector which points between the 2, whereas the pi bonds are actually above and below. And again, it will be more delocalized. So if we were to somehow be able to get a picture of the molecule from the side, the delocalized pi bond would actually be above and below the molecule. So that would be the pi orbital spread around the entire molecule, whereas each of the sigma bonds would be more local to the molecular structure. It would be more spread throughout like that. And this is kind of a rough picture for an sp2 hybridization as well on the nitrogen. Okay. So for NO3, there's our 3 resonance structures. The actual structure is in actuality an equal mixture. The hybridization of the nitrogen is the same, and there's a sigma bond and pi bond in each of the structures. Okay, so I'll say this is correct. Okay. And I think I'm gonna end it there. Okay, so that's all the questions for this session. If you enjoyed them, please subscribe to the OneClass channel. If you want to leave questions, follow the links below the video. This has been Jeff Kress for OneClass. Thank you.